instilled in our DNA. And in little boys, you can take young boys, give them a piece of steel, and the first thing they'll do is sharpen it. The idea is that they can either stick it into each other, or they can cut something with it, or they can mutilate a tree, or they can do something with a sharpened piece of steel. And that is, they're never taught. They've never been to a blacksmith shop. They've never seen somebody sharpen a knife. They've never been allowed into their mother's kitchen drawer, but they do it instinctively. You give little girls a bedspread and 2 chairs, what do? They make a house. Women are taught to make a shelter. Men are taught to make something sharp with which to either get food or stick into each other after a bad night. Now, I must acknowledge Des Horn, my dentist, who is a superb knife maker. He was a very good dentist, and he eventually stopped practicing as a dental surgeon and has gone making knives full-time. And I think he's recognized today as one of the world's top knife makers. I was very privileged to spend 3 days with him learning how to make a knife. And at the end of the 3 days, I said to him, Des, do you think I should give up my plastic surgery? And he said, whatever you do, don't give up your day job. So it's not my day job, it's a hobby. And what I'd like to do is just very briefly show you how we make a knife. People have been making knives for centuries. And as metallurgy has improved from making just sharp flints, bronze instruments, bronze knives, and eventually high-quality stainless steel knives. They've gone through a whole progression, and it involved from the earliest discovery of iron. Iron itself is unfortunately very brittle. And you went into battle with a pure iron Fe sword, and you hit your opponent on the head. It was very embarrassing. The sword would break with often, embarrassing or sometimes fatal consequences. So man learned to make alloys, and the first alloy that was introduced into iron was carbon. And we're all familiar with the terminology carbon steel. Carbon steel is very tough, very hard, retains a very good edge, but is high maintenance that if you let it damp, put it away damp, it rusts. And we're all familiar with our grandparents' old carving knives, those lovely old sets in those sort of blue Walker and Hall packages, that if you didn't dry them properly, they rusted. And it took a lot of work to get them nice and clean again. Stainless steel is a new invention, relatively new. It was discovered by adding chromium. Chromium is the component that stops steel from rusting, provided it's up to and more than 11%. It must be 11% and more. All right, I'm going to show you how I make a knife. Let's see where we go. We go enter. Yeah. Shall I put that on? Yeah. I think he's taken it. No, he's taken it. Oh, is this the mic? No, he's taken. Hello? Hello? That's your mic. I think you took the other mic away. Anyway. Right. You do a course. You go and spend some time with a knife maker. Knife makers, unlike plastic surgeons, love people to come, novices to come and spend some time with them. We will do that as plastic surgeons. If he's in the same town, we'll give him all the wrong information. If he's from another city, another country, we welcome them. But knife makers generally are generous with their time, generous with their information. And Des Horn is like that, and all the knife makers I know are like that. You get the books, there's dozens of textbooks, and as I visit a knife making friend, and there are clubs. Every town has a knife making club. It's a very popular hobby. It attracts a lot of people who previously were in the industries of heavy machinery making, panel beaters, that type of thing. They always look at me when I go to my club. They always say, you know what, he's a plastic surgeon. And I feel a bit embarrassed because they're all basically journeyman artisans. Let's see, let me get this right. Sorry. Right. You need a certain amount of equipment. My first knife I made in my garage on an upside-down Makita 4-inch belt sander. Left it on the ground. If you think about it, the potential hazards, it's phenomenal, but nevertheless it's fine. I made my first knife. You turn the angle grinder, leaves the belt sander upside down, and you grind your piece of steel. And we'll talk about steel later on. But when you get going, you need a vise, you need files, angle grinder, belt grinders, a furnace for heat treating, you need a polisher, wet and dry paper, a drill press for accurately drilling holes, and lots of energy, lots of elbow grease. It's also, it's dirty. Unfortunately, whenever you grind steel, anyone who's ever ground steel, you know you get a lot of black sort of powder. You've got to wear proper ventilation protection, you've got to wear a mask and protect your eyes and hands. That's my workshop, and as you can see, every aspect of health and safety is closely adhered to. That's a horizontal belt grinder. It's got a platen there. That's one of the belts I've just taken off. It goes around the motor there, comes over the top, and you can also do things across here. This is a horizontal one, which works in the other way, and it's got different size polyurethane coated wheels, so you can grind the sort of curves and some of the sort of shapes of your knife. I like using African hardwoods for my handles. You can use anything for a handle, from plastic, mother of pearl. I love these things, which mainly are African hardwoods. This is African blackwood, and what they are essentially are all offcuts. You go to Ticton Timbers, you go to Rare Woods, and you ask for their offcut section, and they are very happy to give you a big bag full of these things for about 20 rand. They're only too happy that you take them away. Antlers, fallow deer antlers, which are plentiful in the Eastern Cape. And this wonderful wood here, which is called sneeze wood, Nieshout, also indigenous to the Eastern Cape. It's incredible. That piece there is probably about 300 years old, and it stood in the Cape weather, in the East Cape weather, for 300 years. And it looks terrible on the outside, and you cut through it, and it's the most beautiful heartwood, beautiful, beautiful wood inside. And then there's desert hardwood. This is a kind of hardwood species that comes from Namibia. Also very, very hard. You want woods that are hard, that are stable, are not porous, so that when you wash them, the water won't get through, and don't shrink. So once you've positioned it accurately on the handle, it won't shrink. So this is my little wood pile, which actually is the view from our kitchen window. Paula, I will one day clear it. This is a polishing machine. Your final steps in the manufacture is putting a high quality polish. It's a dangerous machine in that you've now got a sharp instrument, and if that wheel, that felt wheel, catches the tip of that knife, it wrenches it out of your hand, it bounces off the top wall, and it's in your femoral artery and vein before you know what's happened. So knife makers have died from this very injury. Somebody died in America recently. He got a ricocheting blade off the wall into his femoral artery, and by the time they got him, he'd bled out. So that's the polishing machine. A furnace. The steel that we have, or I'll get, is annealed. By that I mean it's softened. After the process of melting the alloy, extruding it, and making a sheet, it's soft. It's relatively soft. It's too soft to actually make a knife out of, but it's wonderful to work with because you can drill it easily, you can mold it, you can file it, and do all sorts of things with it, work it very well. It then goes into the furnace where it's hardened. There's a whole chemical structure change when you harden it. It goes up to 1,100 degrees for half an hour, and then you quench it, you cool it down very rapidly, and the molecules change their structure and they get very tight and very hard. Unfortunately, anything that's very hard is also very brittle. So after the hardening process, there's a tempering process, which is in your ordinary oven, 200 degrees for 1 hour. You need a vise, a decent vise. That's got a copper, this is an old piece of copper, which I've put there because all vice have very hard metal teeth, and if you put your beautifully polished blade in there, you go back to square one, you get a whole lot of indentations and scratches on your blade. So the copper, softer than steel, it just protects your blade. Right, so now we get to the design. Every knife has a particular function, and that is a tomato, obviously. That is a Bowie knife. Jim Bowie was a Texan knife maker in Texas, and the Mexicans, when they were fighting the Mexicans, had a short dagger, and you know, in close combat, these Mexicans were actually damaging the Texans. So Jim Bowie, in typical American fashion, got down on his drawing board and he designed this knife, which I'm not exactly, the blade is about that long. And that knife is made for only one function. It's not peeling tomatoes. That knife is made for sticking into people. And it's a very, very effective way of combat in a man-to-man situation. That's a little paring knife. That's a little domestic paring knife, and that you would use every day in your kitchen for peeling a tomato, slicing a tomato, carrots, you know, whatever else, your vegetables. But so every knife, the function dictates the form. On the title of my talk, they talk about smithing, blade smithing. There's a difference between a knife smith and a knife maker. A knife smith is somebody who has a forge, a large thing of charcoal with a blast of hot air in it, and it gets to very high temperatures, and you put your steel, which may be anything. It can be old ball bearings, it can be old Chev springs, it can be anything you've retrieved from a metal scrap heap. And you put it into that forge, you get it nice and malleable, and you beat it with a hammer. A typical blacksmith you see in a darkened room, it's darkened because he knows, he can see the color of the steel, because steel has to be a specific color before you can do things there. And that's why all the smith shops are quite dark. That is smithing, where basically you've seen these guys, they have wispy beards, they usually live on a small holding on some remote part of southern North America, and corduroy dungarees or denim dungarees and a leather apron, big arms from all the hammering. And they have wives, and anyone who's been to the Sedgefield Saturday morning market, they have wives like that who have lovely long dresses, unkept blonde hair, and they make yogurt and artisan cheeses. Anyway, that's and they've got that's right, they have lots of tattoos. I do what's called a stock removal method. So our steel comes in a bar form. It's already, the whole forging process has occurred at the factory in Germany or in Sweden. They've taken the lumps of steel and they've heated it up and they've melted it and they've banged it and they've made it nice and thin into 3 to 4 millimeter thick strips. So that's how what we're going to do, we're going to remove steel to get our shape. So planning and drawing, first stage, you've got to decide what kind of knife do you want to make. You do it on paper. These are just little paper patterns done on paper, cut out. And I love this design. I enjoy cooking, and I find this is a very practical design, because what you've got here is a paring knife. You've got something you can pare, you can slice, you can peel with. And the nice thing, if you're chopping, you can also chop, the old-fashioned chopping up an onion. And then this is wide enough that you can then pick it up and put it into a pot or a pan. So that's your paper pattern. And then you draw that out. That's a piece of metal, a piece of Swedish steel called nitrobe 77. And just a brief note about steel. Carbon was introduced into all high-quality steel that had to do heavy work. And it unfortunately, they call it dirty steel, because when you grind it, you get this little black dust. Now, what the Swedes have done, are very clever. They've removed carbon and they've put nitrogen. How they do it, goodness only knows. They put nitrogen into the steel, and the nitrogen takes on the job of the carbon. In other words, it makes it very tough, very hard. So the name of it is nitrobe 77. I managed to get some of this through Des Horn, who was able to export it from the Damas steel manufacturers in Sweden. And then they stopped making it for a very simple reason. This is such fantastic steel that most of the steels that we use as knife makers are designed for the meat processing industry. Blades in emulsifiers that make bologna and sausage and what have you, and have to cut a lot of meat and tough sinews and stuff like that. Nitrobe, Damas Steel said to their people that make the blades, would you try some of the steel? And they did. And they came back to the manufacturers, Damas Steel, and they said, can we ask you to do something? Please, we don't want any of that steel. We want the same steel that we've been using. This takes, they only have to sharpen it every 3 or 4 years. The previous steel, guys from the factory go and they sharpen everything every year. And it's a bit like ink in printers. You know, they don't make their money out of the initial thing. They make it out of servicing the industry. So we can't get this anymore, and it is the most fantastic steel. And that's now, the metal has been cut out. That's been cut out. And just a quick explanation. These holes, this is pre-hardening. These holes here allow one to pin the bolster onto the handle. This is going to be the handle area, obviously, and there's 3 rivet holes there that are going to hold the handle. These holes here lighten the steel. You don't need all that. You don't have that doesn't need to be solid. And what it does, it gives you a lovely balance. So when you're working with a knife, it must be beautifully balanced. The fulcrum must be at the bolster. So you hold it with your finger, that knife must be nice and comfortable and balanced like that. We do this pre-hardening because once you've hardened the metal, you can't drill it. You've got to use special tungsten drills, and they're very expensive. And that's the knife when it's finished. That's got an African blackwood handle. It's got 2 brass rivets, and it's got a brass bolster. And that bolster is got 2 2mm rivets that have been pushed through and then peened. You're all familiar with that little funny hammer that's got one end that's got a flat surface and the other end's got a round surface. That's called the peen. That's called a ball peen hammer. And you peen it very much like a riveter in the shipyard. You bang that, and it actually enlarges the end of the rivet, so it fills the hole. So that when you've ground that and cleaned it up and sanded it and polished it, you can't actually see that that's held by rivets. This is called a santuko. It's a Japanese design, and it's without doubt my favorite knife. Steel selection, there's a vast quantity of steels. What Des Horn said to me, which actually bears a lot of sense, don't waste your most expensive commodity is time. You're going to spend as much time on a cheap piece of steel as you're on an expensive piece of steel. Rather use good quality steel, because the actual time you spend is going to be the same. So my mates at the knife club, they've got ball bearings from helicopter rotors, they've got ball bearings from ships, they've got these great big things like this, which have to be heated and beaten and everything like fantastic steel, but it's not stainless steel, it's high carbon steel. So rather high technology, powder metallurgy steel. Again, just to mention powder metallurgy, when you make an alloy, the guy in the furnace just chucks a whole lot of different things in, the steel, the iron, the chromium, the magnesium, molybdenum, all these different components that make up high quality steel. It's melted and then it's extruded, but it has a fairly coarse crystalline structure. Now what they do with the new quality steels is they powderize each component the texture of talcum powder. You then can homogenize that, heat it up and melt it, and you get a much, much fine granular structure. So that's a little bit about, so you don't need to worry about it. That's how I get my steel. It's these rather rusty strips of steel, and they come from either from Germany, Austria, or from Sweden. Sweden, I must say, is making the best steel. Now this is something else. This is Damascus steel. You're all familiar with the term Damascus steel. Why Damascus steel? What happened? The early sword makers knew that they had carbon steel, which was very, very hard and very strong, would cut through things, but it was a bit brittle. So when you went into battle, and I say if you hit a guy on his helmet and your sword broke, it was embarrassing. So what they did, they found steels that weren't as hard but were flexible. You could take a piece of the steel, bend it like that, and it wouldn't snap. And they made a sandwich, very much like bread in a packet. They made a sandwich of all these 2 steels, heated them up, and then banged them together, and the molecules fuse. They don't melt together like an alloy. They actually get very, very closely adherent to each other. You cannot separate them. And I've made these 2, and what I've used in between these, we get old saw blades. We just go to sawmills and we say, we want some of your old, and they just give you this pile of horrible looking metal, and you cut them up with a guillotine, and you pack them together in a little box. And we put sheets of nickel. That lighter color there is nickel plate from the printing industry. And these are typical tricks of knife making. You don't spend a lot of money, you go and get all the refuse from the various things. So metal from the photogravure industry, when they print a photograph, they have these very fine sheets of nickel, little holes in it, and the ink goes across and it comes through at certain places. So those pale areas are nickel, the dark areas are one steel, and the lighter grey areas are another steel. And you bring out this pattern by immersing it in ferrous chloride that etches the metal, and it gives this very decorative pattern. The top quality samurai swords are made like this. The Japanese were masters of it. The Indians were the ones to find it. The Japanese perfected it. Damascus steel. Why it's called Damascus, I don't know. They never originated in Damascus. Cut the outline, drill the holes for weight reduction bolsters and handle pins. And this is now a batch of knives I've made. They've been heat treated, and that heat treating gives a sort of mottled appearance. They all look a bit sort of moth-eaten. You can see the holes we've drilled. This is a French pattern. We call that a French pattern chef's knife. That's a filleting knife for filleting fish. These are sort of smaller hunting chef's knives. These are going to be steak knives, Argentinian steak knives, and those are just a selection of paring knives, what you call paring knives, for utility in the kitchen. Hardening, tempering I've spoken about, and we use a belt grinder now to remove the steel and to give what we call a double tape. You look at a knife, it tapers from the handle to the tip and from the spine of the knife to the blade. And we hand sand to remove all the belt scratches. That takes a lot of work. Pin and pin the handles and handle scales I've mentioned. Polish, sharpen, then finally brag. And that's just a paring knife for the handle, African blackwood handle. There must be no air in there. There must be no gaps between your joints. It must be absolutely airtight. And there's other applications. You can make a nice pizza knife or a focaccia knife. These are two lap knives called puccos. That's used a bit of Damascus steel, and that's antler and stainless steel. That's just a selection of different knives. And just a word about safety. You can buy commercial knife guards to keep in your kitchen drawers, which have two functions. One is stop you cutting your hand when you put your hand into the drawer. The other function is to protect the sharpness of the blade. Finally, there's nothing like a sharp knife. And I recommend Japanese whetstones. They're fairly expensive, but they last a lifetime. And you get them in different grades, and you want a nice fine grade. Most commercial whetstones you buy from hardware stores are much, much too coarse. They're horrible grey, grindy sort of things, damage the blade, and although they do serve a function, they're not as nice as a good quality Japanese whetstone. Test of sharpness is to take a piece of paper, and you can cut what you call a curlicue. You can do this little, and it sort of makes a little picture, just uneffortlessly cuts the edge. I found a better way was to take the hairy forearm of my youngest daughter's latest boyfriend, and you can actually shave the hair off. And there's a subliminal message there which invariably gets through. Thanks very much.